So here is phase 16. So we're going to go back to volumes with known cross sections, but this time we're going to have to draw the region that is the base of the solid that the, shapes are popping out of. And we're actually going to be given functions instead of me just saying like f and g or r and s or whatever. Okay, so region R is the region bounded by this parabola, this line, and the y-axis, but then I had to add this on because this wasn't clear enough, in the second quadrant, okay? So first we're going to find the volume of the solid whose base is R, the region that they just described, and whose cross sections, when cut by planes perpendicular to the x-axis, are equilateral triangles. And then we're going to go do down here with squares cutting in the opposite direction. Okay, so first, guys, you've got to draw a nice, big, clear graph. And I already started by, graphing this. And so I can't really see this very clearly. I want to go up higher. I know the parabola and the line are going to intersect like off in that direction, but I can't really see it that great. So I'm going to go to window and I'm going to make my y max. Right now my y max is 10. That's the highest y value I can see. I will make it, I'll make it 30. All right, let me turn the light on too so you can see the screen better. All right, I think that will be better. Hopefully. Not really. Okay, so the region, if they didn't say the y-axis as well, then we could, just say the region is this. That would be the region bounded by the line and the parabola. But they also said the y-axis. Now, if you take the y-axis into account, you could look at this region over here, but that's in the first quadrant. They want the region in the second quadrant, so it's going to be that region there. So when I draw my picture, I'll show the y-axis, here's the x-axis. I've got this parabola, but I'm only considering the half that's in the second quadrant. And then, the line is like that. Okay, so that's our region right there. Okay, now the next thing I'm going to do is get these intersection points. All right, this one here is 0, 2. That's where the parabola starts. This one here is 0, 11. Okay, that's the y-intercept of the line. Now this one up here, I'm going to have to use the intersect thing. So I go second calc, intersect. You hit enter 3 times. Here is our intersection. I'm going to need to store those. They are decimals. Okay, so up here, just for my reference, this is like negative 4.162, and then this one is 19.325. But I'm going to store them. I'll store this as A, and I'll store that as B, and I've got to show my reader. So I go to my home screen, I hit X, okay? So I'll just tell my reader right here, negative 4.16227. All right, and this doesn't even have to be, just write, some of the decimals from your calculator. I had been writing all of them, but this is enough for your reader to know that this is stored as A. Now, for B, oh, it's not there anymore. But for this y coordinate, I just plug this value A, which I just stored, into either of these two graphs. So I guess I'll use the squared one. So y equals a squared plus 2. All right, so I already stored, oh, I didn't even store that yet. Be careful. Lots of times I write down on my paper that I stored, but before I actually do. All right, so now that it's stored as A, so now I'll just go a squared plus 2. Yeah, and you wrote those down so you could verify. There it is. Okay, so this is 19.3245. That's stored as B. Okay. So I've got my intersection points. This is the region that is going to be the base of my solid. All right, now for number 1, we're going to find the volume of the solid whose bases are this blue region and whose cross sections, when cut perpendicular by planes perpendicular to the x-axis, are equilateral triangles. So here's these would be like the bases. These lines would be the bases of the cross sections cut perpendicular to the x-axis. So we're going to be using top minus bottom. Okay. Now guys, I want to use this picture again. So when I do my little triangle, I'll put it like, I'll put it like out here. All right, so that's an equilateral triangle. And the equilateral triangle formula depends on just one of its sides. So we're gonna use the base that is in the plane. And we're gonna be using top minus bottom. And guys, ask yourself, do the top and bottom ever change? Top is the line, bottom's parabola. Top line, bottom parabola. Top line, bottom parabola, all the way to the end of the region. The top is the line, the bottom is the parabola. Now, since we're using vertical slices, everything in terms of x. Okay, so this is number 1. Volume is equal to everything in terms of x. Let me write down the formula, actually. X equals A to B, the area in terms of x dx. Okay, volume equals the integral. What is the leftmost x value? A. Capital A. The rightmost x value is 0. Okay, now in here, I need to put the area of this equilateral triangle using top minus bottom. So here's all your area formulas. Equilateral triangle right here. Okay, radical 3/4 b squared. So radical 3/4 b squared. So radical 3/4 b squared. Now, how am I going to find b? This is the base, b. I need top minus bottom. So the top is the line, 11 minus 2x, minus the bottom is the parabola, x squared plus 2. Okay, and be very careful with your parentheses. All right, now I'm going to use math 9. Oh, and you know what? I did it again. I didn't even store that as b. Shoot, darn it. Okay, a squared plus 2, right? Okay, store as b. Now it's stored as b. Okay. So I go math 9. All right, and I'm going from a to 0. Radical, wait. Radical 3/4, parentheses, 11 minus 2x. I'm going to distribute that negative just to avoid more parentheses, minus, but be careful, x squared minus 2. Close parentheses, that's the whole base, square it, dx. Okay, so the volume, 113.531. Okay, you do not want to round your answers along the way, guys, but final answer is 3 decimal places. Okay, now the second part. Find the volume of the solid whose bases are, same region, and whose cross sections, when cut by planes perpendicular to the y-axis, are squares. So this time, guys, our cross sections are going to be cutting through perpendicular to the y-axis. So we're going to be using right minus left, so things are going to be in terms of y. Now, you want to ask yourself, is the right and left always the same? Okay, so right here, right is the y-axis, left is the parabola. right y-axis, left parabola, right y-axis, left parabola. But then at this point here, guys, right is the line, left is the parabola. Right is the line, left is the parabola, all the way to the end. So we're going to need two integrals because the right minus left is going to be different. All right, so I got to do something in a second, but let me just draw. Okay, so here's a square. Pretend that's a square. All right, and we're going to do right minus left. Okay, so we're going to use squares like that all the way up to here. And then here, shoot. All right, I don't know, I'm really not a good artist. All right, that's a square. And if you can imagine this like without drawing, that's fine. Then the right minus left is going to change. Okay, now, because we need things in terms of y, you need to solve for x. All right, in terms of x, y is solved for. In terms of y, x is solved for. So let me do like a little aside. Aside, okay. Aside. Okay, so the aside. I'm gonna take y equals x squared plus 2. I'm going to solve for x. So x squared is y minus 2. X is plus or minus radical y minus 2. Now, when you end up taking a square root and getting a plus or minus, you ask yourself, are these x values, are the x values over here positive or negative on the parabola? They are negative. So we're going to be taking the negative. We're going to be taking the negative version there. You could just cross out the positive. And then for y equals 11 minus 2x, negative 2x equals y minus 11, x equals y minus 11 over negative 2. Okay, so there's what we're going to be using. This is the line, and then this is the parabola. Okay. So now this is number 2. I'm going to need two integrals. Okay, so the first integral is going to be going from a bottom y value of 2 up to a top y value of 11. So the integral from 2 to 11. Now I need the area with respect to y. Or actually, let me go like this just for our notes. And then I will need the area with respect to y dy plus, then we're going to pick back up, I wrote 2. Then we're going to pick back up at 11 and go all the way up to b. So then we will pick back up at 11, go all the way up to b, and we will have another area with respect to y. And guys, for a square, the area is just base squared. Okay, so this really should not be too bad. So the integral from 2 to 11, was I saying the area from? Okay, and then I'm going to have to do base squared dy. All right. Now from 2 to 11, the right is 0 because the y-axis is x equals 0. The right is 0 and the left is the parabola. So it's going to be 0 minus negative radical y minus 2. All right, and then you're squaring that. And you could totally simplify that. I would if I was on my own. And then plus the integral from 11 to b. All right, and then I'm going to be squaring this dy. Okay, here I need right minus left again, but this time right is the line, left is the parabola. So the line is y minus 11 over negative 2 minus the parabola is negative radical y minus 2, okay? And you could totally simplify stuff. All right, so now in my calculator, I'm just going to plug all that stuff in. So, math 9. So the integral, and you should try this along with me, guys, if you got a calculator in front of you. The integral from 2 to 11. I had to focus. All right, the integral from 2 to 11. And then this is just radical y minus 2, but you got to use x. And then it is, it's squared. Wait. No, I don't think you need parentheses like I'm doing, but let me just be consistent. Radical, you definitely don't need them. Y minus 2 squared. I just wanted it to look like my paper. X plus math 9, 11 up to b, which I did store, and then this thing. So x minus 11 over negative 2, and then we could just say plus, because it's a double negative, x minus 2. Okay, wow, smaller. I wouldn't have expected that, but okay. So 53.249. I would have expected that to have a bigger area for some reason. It just looks bigger on my paper, I guess. Okay, guys, there it is.